Hello everyone, and welcome to this first lecture on organic chemistry. We will look at what organic chemistry is and the special chemistry of carbon. Organic chemistry is basically the chemistry of life, and it's the study of organic compounds. That means compounds that contain the atom carbon. And here we have different ways of how we can represent different molecules containing carbon. We have molecular formulae, structural formulae, and we will also look at condensed formulae, which we will get in at a later stage. Carbon can really make a variety of bonds due to its valency, as you can see over here, and we will look at that in more detail shortly. Here we have an example of a chemical reaction that is typically not an organic reaction. This is the formation of elephant toothpaste. It is made basically by putting hydrogen peroxide and potassium iodide together. Potassium iodide is just a catalyst that will oxidize the peroxide in this case, but there's no carbon in these two reactants, and so no carbon product can form. This is not an example of a typical organic reaction. We typically look at something like this for any organic reaction. Well, these are combustion reactions of organic substances. Not all organic compounds will, of course, go hand in hand with flames. But if we look at organic chemistry, carbon is the basic building block of all organic compounds. Now, you have to know the formal definition for an organic molecule. These are molecules containing carbon atoms. Carbon, as you can see, if we do a Lewis structure of this, remember that the Lewis structures of atoms basically shows the outermost electrons as dots or crosses. In this case, we show the outermost electrons as dots. Now, carbon, as you know, has 4 valence electrons. And we can show these valence electrons basically by this structure. You might ask why the Lewis structure of carbon does not look like this. Well, this is because carbon is actually really special. It bonds to all other atoms in its excited state. Let's quickly explain that. So carbon in its ground state will have an electron configuration looking like this. We start with 2 electrons in the first energy level. Then we go up to the second energy level, and the electrons that we will fill will be filled as follows. In the 2s orbital, we have an up spin and a down spin electron, and in the 2p orbitals, we have only 2 single electrons in the x and y p orbitals. But this only gives carbon a valency of 2. Remember, valency means bonding possibility of an atom. And so there's only 2 unpaired electrons, which means that carbon in this ground state would only bond to 2 other atoms. But carbon is the building block of life, and so it has to bond to a maximum number of atoms in order to build the variety of compounds we find in nature, including ourselves and all other living organisms. So carbon, with just a little amount of energy, will then hybridize its orbitals to, in fact, just attain the excited state where you now have, instead of just 2 unpaired electrons, you have 4 unpaired electrons. And you could really look at that by saying that this extra electron here got excited to that M2p Z orbital. So but we call that hybridization, which we will not go into detail at this stage. This then gives carbon a valency of 4, which is really its maximum bonding possibility that it can have. And then it can also bond to 4 other atoms whenever it bonds. So you need to understand that carbon is special. It is the building block of life. We find it in the carbon cycle, present in the air, in soil, in water. It is the basic building blocks of all living organisms. And because of this, it has to bond to a maximum number of other atoms. And so it will always be found in its excited state with a valency of 4, where it can bond to 4 other atoms. This, of course, will be the Cooper structure of carbon, showing its electrons that it can bond with other atoms to as sticks instead of just crosses or dots. So what is organic chemistry? We said it is the study of of compounds that contain carbon. That excludes carbonates, hydrogen carbonates, carbides, and oxides of carbon, for example, carbon monoxide and carbon dioxide. These are inorganic compounds, and they are not organic simply because of this. They do not contain carbon atoms on a chain bonded to hydrogen atoms. The second you have hydrogen atoms bonded to your carbon atoms, and then all other types of atoms bonded to that basic structure, you have an organic compound. So let's go through this quickly. An organic compound is made from carbon atoms. It can have 1 or more carbon atoms. There's also many hydrogen atoms bonded to that carbon, and it may also contain oxygen, sulfur, nitrogen, and halogens bonded onto the carbon chain. Typical organic compounds have covalent bonds, as I've explained to you just now. They have low melting points and boiling points. They are generally flammable, as you've seen in that GIF. They are soluble in non-polar solvents because they are themselves non-polar, and therefore they are not soluble in polar water.